Multiplying and dividing integers. What are the rules for the signs? The rules are actually really easy to remember. Like signs are always positive. Unlike signs, always negative. I know acronyms. I made up one. SPUN. Same positive, unlike, negative. So keep that in mind. These are just symbolic notations of what's going on. Positive times a positive is a positive. A negative times a negative is a positive. See, like signs give you positive answers. Unlike signs, negative times a positive is a negative. Positive times a negative is a negative. Unlike signs, that's why the answers are negative. Same rules for division. Same rules for division on or like signs and different signs or unlike signs. The real reason why these are what they are, it's all based on the rules for addition. I may show you with a couple of these what we're talking about. Now let's do these. 2 times 3, you better know that that is 6. Negative 2 times a negative 3, by the rules, when you multiply two negatives, the answer is a positive. So the answer is a positive 6. Don't mix that up with addition. When you add, you keep the signs. When you're multiplying and dividing, like signs are always positive. Two totally different rules. 2 times negative 3, different signs, so you multiply and the answer is always negative. Same is true over here. Unlike signs, the answer is always negative. Here's the reason why. This 2 plus negative 3 is the same as negative 3 plus negative 3. Because 2 means that you're adding 2 of those. When you add the numbers and keep the signs. Now this is just like this, except we have one additional sign. And so, if we take that one additional negative sign and think of it as an opposite, well, what's the opposite of negative 6? You would say positive 6. But you may or may not understand that, but if you really want to know why, that's the reason why. It's all based on addition. Now the division problems are a little bit easier to understand. I should have written these as in fractions. Here we go. 8 divided by 4 is, of course, 2. Now I'm going to write this in this form so you can see something. And negative 8 divided by negative 4. If you know anything about fractions, you probably heard of the word cancel. Cancel just means reducing down to 1, to a positive 1. So in a certain sense, you can think of these negative signs as canceling out, becoming positives, and it leaves 8 divided by 4, which is 2. Now when I look at these two, and I write these in a proper way, can that negative sign cancel out? The answer is no. So you take 8 divided by 4 is 2, minus sign stays, so the answer is a negative 2. Same is true for this one. Cannot get rid of that negative sign, so it stays. And that's probably a little bit easier way or better way to think of when you're multiplying or dividing numbers with same signs and different signs. Same signs, they cancel out, leaving a positive answer. Different signs you can't cancel, so the negative sign stays. So keep that in mind. The rules for multiplication and division are a lot easier than the rules for addition and subtraction. Let's do these next two examples. When you multiply, this is all multiplication. Negative 2, negative 3, and 9 are all separated by parentheses, which means we're just going to multiply left to right. I'm going to do negative 2 times negative 3, and negative times the negative is a positive. 2 times 3 is 6. And then 6 times 9 is 54. This one is multiplication and division. I just go left to right when it's multiplication and division. So let's do these two. Negative 4 times 8 is a negative 32, and those are different signs. That's why the answer is a negative for that part. And now, a negative 32 divided by a negative 16, I like to do the signs first. A negative divided by a negative is a positive, and 32 divided by 16 is 2. The answer is a positive 2. I'm going to do one more just so you don't do something that you shouldn't be doing. This is not a negative times a negative. This is a negative plus a negative. Negative 2 plus a negative 5 means you add the numbers. Keep the signs when you're adding. A lot of people miss this on two accounts. First off, when they see parentheses, they automatically think it's multiplication, and it's not. The plus sign takes precedence. Even if it's written like this, it's still an addition problem. Another mistake is, People think when they see two negatives, it's automatically positive. That's only true for multiplication and division. When you add and subtract, you keep the sign if they're the same. So if they're both negative and you're adding, keep the sign. Now look at this in these next two examples. A lot of people miss these. Not so much this one. Now here's the way I like to explain it. This exponent of 2 is on the parentheses, which means that the parentheses have been being multiplied twice. What's inside the parentheses, -3, goes in both of these sets of parentheses. And then we multiply. A -3 times a -3. Well, what's a negative times a negative? Positive. 3 times 3 is 9. Now this is the big one that people miss. This is humongous. There's all kinds of ways to explain it. One way is, this is the opposite of 4 squared. 4 squared is 4 times 4, which is 16. Now this minus sign is on the outside. So you can think of it like that. So it's like the opposite of 16, which is -16. The way I like to explain it is, over here the exponent is on the parentheses. That's why I drew two sets of parentheses, and that's why the -3 was in both of those, because it's inside the parentheses. Whereas over here, the exponent 2 is only on the 4. Not the minus sign, not the negative, only on the 4. So that's why I drew two 4s, 4 times 4. The minus sign had nothing to do with the exponent, so I just kept on coming down. Here it's on the parentheses, here it's on the number, not the sign. And then one final way I like to explain this. This is the exact same thing as that. I haven't changed it, because 0 minus 4 squared, 0 minus anything is that. It's as if the 0 isn't even there. But we know that it is. If you think of it like that, by the order of operations, you do subtraction first. 4 squared is 16. And then drop the 0 minus, and 0 minus 16 is -16. You're taking away more than you have. Or keep, change, flip, however you want to look at it. Subtract gets down larger. 16 is bigger than 0, 16 is negative. Watch out for this one. It's worth putting a star beside. Maybe quite a few stars. How about a bunch of them? So just be aware. Big deal. Alright, here we go. This is going to lead us into our next section, order of operations. Remember the order of operations? PEMDAS. Please excuse my dear Aunt Sally. A lot of people know that. P is parentheses, E is exponents, M and the D go together, multiply and divide, A and the S go together, add and subtract, whichever comes first, left or right. Here we go. I see parentheses first. I'm going to do those first. 4 minus 7 is -3. I'm taking away more than I have, so that means I owe 3 more. Next thing is, now when it says parentheses, you do what's inside. I can't do anything else inside, so I'm going to do the exponent now. 2 squared is the same as 2 times 2, which is 4. Notice how I do this. If I'm not using it, I'm bringing it down. The only thing I'm changing is the only thing I can do. In this case, the 2 squared. Now a lot of people make this mistake. They get happy because they've done some work and they want to do 8 minus 4. Can't. You got to multiply and divide before you can add and subtract. This has multiplication. Now when I do this multiplication, watch what I do. I highly recommend this. This is going to avoid a lot of mistakes. I don't see that as a 4. I see it as a -4. And that's what you want to do also. Because the reason why I do see it as a -4, I'm just going to throw this step in just so you can see that it actually is a -4. Keep, change, change. See that? Subtraction same as add and the opposite. Change, change. So it's actually the same as -4 times a -3, which is a 12. Now I didn't mean to do this, but I'm glad I did. I'm glad I used a different sheet of paper. -4 times -3 is a positive 12. Plus that just comes down. I don't need this step. If I take this 4 and see it as a -4, I know it's a -4 based on my rules, my definition of subtraction. I can rewrite it like this. But if you want to save yourself a step, think of it as -4 times a -3 is a positive 12. Notice what I don't say 12, I say a positive 12, that's what I write down. plus 12, then the 8 comes down. And 8 plus 12 is 20. So, as I do these, I'll show you what I do, and I try to show you the way to do it to avoid sign mistakes.